Okay, so here's the question. Maybe I can make it a little bit bigger. Uh, there are a few ways we can approach this. We don't even have to draw out a diagram if we have a really good understanding of what's being described. But I'm going to draw out a diagram because I just think that's going to make this simpler. So we're going to start with activity A, and that is an immediate predecessor for activity C. Looks like activity B and activity A can both start at 0. So let's say this is A, here's the start, and this can be B. Now A goes into C, and C is going to go into E. So that's C. And B is going to go into D. And then C, let me draw this differently. So we're going to have D here, we're going to have E here, and they both feed into F. And F gets us to the end. So this question is saying, how much could we make C longer by without affecting the end time? So we want to think, okay, well, is C on the critical path? Presumably not, if this is the case. Let's have a look. So C can have an earliest start time of 8, which tells us that A must have a duration of 8. D has an earliest start time of 15, which tells us B must have a duration of 15. Now, F can start at 35, which means that ACE must take 35 or BD must take 35. Now, we can see that E has an earliest start time of 22, which implies that C takes 14. So let's see. We know that E takes 2 hours, that's given in the question. So this whole path here takes 8 and 2 and 14, 24 hours. But the earliest start time for F is 35 hours. So this must be 20 hours here. So that means that if A, C, and E all work like clockwork, they finish after 24 hours, but they now have to wait around for 11 hours in order for F to begin. That means that there's 11 additional hours that these tasks could take. So without delaying the end of the project, C could actually take 25 hours. I hope that makes sense.